Hello friends, this is the 12th and the last video of the playlist of data science. So today's topic is association rule mining in data science. Association rule mining is a key technique in data mining that aims to find interesting patterns relationship among the set of items in large datasets. It is primarily used in market basket to analysis to identify items that frequently co-occur in transaction, but it can be applied to many other fields such as web mining, healthcare, and bioinformations. So the key concepts of association rule. Association rule is a typically written as X, Y. If X occurs and Y is likely to occur, X is a antecedent or left hand side, Y is called a consequent or right hand side. Support, confidence, and lift. Support measures the frequency of occurrence of item set XY in the data sets. It is the proportion of transaction database that contain both X and Y. Confidence, the measure likelihood item set Y appears in the transaction that contains item set X. It is the conditional probability of Y given X. Lift measures how much more likely Y is occur when X occur compared to when X does not occur. It is the ratio of observed support to the expected support if X and Y were independent. Frequent item set. A frequent item set is a set of items that appear together in a transaction data set with a support greater than user defined threshold. The goal of association rule mining is to identify these frequent item set and generate rules based on them. A priori algorithm. A priori algorithm is one of most popular algorithm for mining association rule. It uses bottom-up approach where it start finding individual items that meet minimum support threshold and then extend those item set to find larger item set that also meet the support threshold. A priori property. A priori property. All subsets of a frequent item sets must be frequent. This is used to reduce the search space. Example, if the item set ABC is frequent, then AB frequent AC must be also frequent. The algorithm proceeds iteratively, find frequent one item sets, generate candidate two item sets, prove that do not meet support threshold. Repeat the process for larger item sets until no more frequent item sets are found. Next is FP growth algorithm. The FP growth algorithm is an efficient alternative to Aperite. It uses divide and conquer strategy to mine frequent item sets without generating candidate item sets explicitly. It constructs a frequent pattern tree FP tree which compresses the data set, allows frequent item sets to be mined directly from tree, making it faster Aperite for large data sets. Steps in mining association rule. First is data preparation. Data preparation means the collect transaction data, for example, retail purchases, web pages visited, etc. Convert the data into format suitable for association rule. For example, binary matrix where each row represented a transaction, each column represents an item. Frequent item set generation. Apply a frequent item set mining algorithm like Apriori or FP growth to find item sets that meet the minimum support threshold. Third is rule generation. From the frequent item sets, generate association rule that satisfy both the minimum confidence and support threshold. For example, bread butter, which means if our customer buys bread, there are likely chances to buy the butter as well. Fourth is rule evaluation. Evaluate the quality of generated rules using metrics such as support, confidence, and lift. Identify the most valuable and actionable rules for business problem. Now we'll move towards the next slide, which is association rule mining. Introduction to association rule mining. What are association rules? Association rules statement that describe relationship between the items in the datasets. For instance, if a customer buys bread, they are likely to also buy the milk. Application. Association rule mining has application in various fields such as market basket analysis, medical diagnosis, fraud detection, and web uses analysis. Next is the a priori algorithm. As we have read before, a priori algorithm step 1 candidate generation. The a priori algorithm iteratively generates the candidate item sets based on the frequency of individual item. Second is support counting. The algorithm counts the support of each candidate item set, determining how frequently it occurs the data set. Step 3 pruning. The item sets do not meet the predefined minimum support threshold are pruned from the candidate sets, reducing the search space. Next is calculating support confidence and lift. Support. The proportion of transaction containing the item set in the dataset. Confidence. The probability of observing the consequent item set given the presence of anti-set item set. Lift. A measure of strength of association indicating how much more likely the consequent item set is to occur when the anti-set item set is present. Next is the applying confidence difference creation. There are three steps. As you can see in the PPT, there is a triangle in which the first is definition, second is rational, third is example. Definition. The confidence difference creation compares the confidence of rule to the confidence of its reverse rule. Rational. It helps to identify rules where the presence of antecedent item sets significantly influences the occurrence of consequent item sets. Example. If the confidence of if bread then milk is high, but the confidence of if milk then bread is low. The creation suggests a strong relationship. Next is implementing the confidence difference creation in R and Python. First is R implementation. Use the Ario's package to calculate the association rule and apply the confidence difference creation to identify strong relationships. Second, we'll discuss about the Python implementation. Utilize libraries like MLExtend to extract association rule and implement the confidence difference creation for rule evaluation. Now we'll discuss about applying the confidence quotient creation. Definition. The confidence quotient criterion compare the confidence of rule to an average confidence of all rules containing the same antecedent item set. Rational. It assesses whether the confidence of specific rule is significantly higher than the average confidence or not. For example, if the confident quotient is high, it indicates that the specific rule is more likely to hold true than other rules with the same antecedents. Now implementing the confidence quotient criterion in R and Python. Python code. Utilize the ML extend library to generate association rule and calculate the confidence quotient for each rule. R code. Employ the Arrows package in R extract association rule. Implement the confidence quotient creation for the rule evaluation. So now we will move towards the key takeaways and conclusion of this video. So the first conclusion of this video is powerful technique. Association rule mining can uncover hidden patterns and valuable insights in the large datasets. Second is practical applications. It has broad application in various fields from business to healthcare research. Third is implementation tools. R and Python provide powerful libraries for association rule mining and rule evaluation. So this was all for today's video, and this was all for this playlist of data science. Hope you will like this video and this playlist. If you like this video, hit a like button, subscribe the channel, comment down below, and save this playlist. Thanks for watching the video. Bye.